So my list number is URK17CS174 and this is sixth experiment, the data structures lab, and this is W linked list. So for the W linked list, we first have a structure here for each node. In this we have a data, we have two pointers, a next pointer and a previous pointer. And then we have a class DLL, it stands for W linked list. In a private attribute we have created a node pointer named head, which will point to the first element in the list. And we have a constructor, we have three types of insert functions: insert at front, back, pause, and also a fourth variable which is middle. We have a display function and also three types of delete function, which is delete the front node, delete the back node, and delete node at the position. And we also have a function to make our linked list nodes. So in the constructor all we do is initialize the head to null, and in the make node function we make our linked list nodes. We'll take a parameter x, we'll allocate space for the node, we'll set the next and previous pointers to null, and assign the data attribute to x, which is the parameter, and return the node. In our insert friend function we will be taking a parameter and we will be making the node for it, and then we'll be checking if the head is equal to null. If the head is equal to null, we will assign the head to our newly made node. Otherwise what we'll be doing is we will be inserting at the front, and we'll be reassigning head to our newly made node. So our newly made nodes next will be the old head, and temp dot will be our new node, and finally we'll be assigning head to our new node. Then comes the insert back function, which will again take a parameter y, and we will be checking if head is equal to null. If it's equal to null, we will be calling the inserted front function, which is on top, because if head is equal to null, this means that the list is empty, and hence we can just call inserted front and insert the element. Otherwise what we'll be doing is we will be making a temp node head, equating it to head, and then we'll be taking another node and allocating our new node, and then we'll be traversing to the end of the list using the while loop, and then we will insert the node at the end, where we will do the last node dot next equal to our new node, and our new node's previous equal to the old last node. And then here comes our inserted position function, which takes two parameters: one the data, and second the position. And if the head is equal to null, we will be calling the inserted front function, or even if the position is equal to 1, we will be again calling the inserted front function, because this will make um, our function easier. Otherwise what we'll be doing is we will be creating a node using the make node function, and we will be traversing to the position and then inserting the function, inserting the node here. Hence this is the final part where the node gets inserted, and we'll be reassigning the pointers accordingly. And then comes a display function. In the W linked list we have two types of display: forward and backward. For the forward type, what we do is we start a loop at the head and traverse to the end of the list, and at each stage we'll be printing the elements value. And for the backward function, we will first traverse to the end of the list, and we will be using the previous pointer to come backward and print the values at each stage. And after that we have a delete friend function, which will delete the head of the list, and then reassign the pointer to the next node in line. And if before deleting, we will always check if the head is equal to null, because this will generate an error. If it's null, the list is empty and we can't delete, so we will be doing this here. And after this is a delete back function. Again we'll be checking if the head is equal to null. If it is equal to null, we will print out an error message. Otherwise what we'll be doing is traversing to the end of the list here using this while loop, and later we'll be deleting the element using this part of the code, where we delete the element and return the value that it held. And now it's the delete position function. We'll be taking a position number as an argument, and we'll be checking if the list is empty. Again, if it's empty, we will return 0 and also print out an error, and if it's 1, we will call delete front. Otherwise what we'll be doing is we will be traversing to the position of the node that we want to delete, and we will be reassigning the pointer here. And finally we will adjust our list so that our list is intact. And this is the final driver program, which is the main program. We'll be creating an object and we'll declare the variables that we need, and we'll be displaying an menu to the user. From this 7 options, the user can call any of the function. We have a switch case to call the appropriate function based on the cases. And also we have a default case here that will display an error message if anything less than 1 or greater than 7 is entered as an option. And after that we have a check here. At every stage we have to keep entering y, otherwise the loop will break and our program will terminate. So let's run this program. So I'll be inserting at front. I will insert 10. I will continue, and then I'll insert back. I'll insert 20. I'll continue, and now let's look at the list. We should be able to do forward. So 10 and 20. I will continue, and I want to display it again, but this time we'll be backward, so we should get 20 and 10. So as you can see, 20 and 10. So now let us insert 30 at position 2. So insert position, and the value 30, and I will insert at position 2. So after this, let's display the list. We should get 10, 30 and 20 as the list. So we'll display it forwards. So as you can see, we're getting 10, 30 and 20. Then what we can do is we'll try deleting this time. So we will delete front, continue, and I will delete back, continue. This time the output should only be 30. So as you can see, only 30 is left. So all the proper functions, sorry, all the functions are working properly in this program. And this is the end of the sixth experiment of the DS6 lab. Thank you.